Okay, these are some more problems, and this should be 6.4, not 6.3. Sorry about that. Let me just change this here. This is 6.4. Okay. There we go, 6.4. And this is number 10. And these are again the differential equations we're solving by separation of variables. So we have given dy dx equals 4 times the square root of y, natural log of x over x, and then y equals 1 when x equals e. So again, we proceed the same way. We separate the variables. We get all the y's and dy's on one side and everything else on the other side. So I've got my dy, so I can put the square root of y on the bottom, and then I can put the dx over here with all of this. Then I can bring out the 4, and I wrote this as an exponent. And I have this 4 times the natural log of x. Now, this is a kind of a tricky one because the natural log of x, what's the derivative of the natural log of x? 1 over x, all right? It's not going to be 1 over u du because the derivative of x is 1, so I've got extra. You can't have extra, you have to use up everything you've got. So if I take the 4 out, and I think about the natural log of x, the derivative of the natural log of x is 1 over x, it looks like I might have u du, or u to the n du when n is 1. So I kind of rewrote it so it would be kind of bias you towards that, so I put the 4 out here. The natural log of x times 1 over x dx, so I let u equal the natural log of x. So du equals 1 over x dx, so I did substitute both those at the same time. So this is u, and this is actually going to be du, and it looks like I've got u du. And I put this up on the top so I could use the power rule on that. Okay. So the antiderivative of this, I'll add 1 and divide by that. So if I add 1 to negative 1/2, I get 1/2. I divide by 1/2, it's like multiplying by 2. And then this is 4 times, and this is going to be u squared over 2 plus c. And I can substitute back in now. My u is actually the natural log of x. So I've got 2, and then I can write this as a square root. So it's a little more functional. So 2 times the square root of y equals, and 4 over 2 is 2, so it's just 2. And u squared is the natural log of x squared plus c. I can divide both sides by 2. Now, we take a lot of liberties with the constants, so be aware of that. I divide by 2, 2, and 2. This is what we have. Now, this is where you take an awful lot of liberties with the constant, because if you take the square root if you square both sides, you know, you would think you might have an internal term, but no, the c, you could have shifted the c over here and squared both sides and worked it out. So you can take liberties with that, and you can square both sides. So and kind of hide the c till you're done. That's the way it works out. So this just becomes y equals, and if I square this, I get the natural log of x to the 4th plus c. Okay? And now we're ready to kind of find out what c is, because we have our conditions, remember, way back up here. Y equals 1 when x equals e, so let's make those substitutions to find out what c is. Okay? So I put 1 in for y when x is e plus c. But remember, the natural log of e is just 1, so I've got 1 equals 1 to the 4th plus c. So if I subtract 1 from both sides, it just implies that c equals 0. So c equals 0 anyway, so that was nice because of all these little hijinks we were doing by taking the square root of both sides or squaring both sides. So I'm glad c was 0. Makes me feel a little bit better. Okay, so then y equals the natural log of x to the 4th. Oops, that should be a parentheses around there. Pardon me. Or we could write it y equals, in the abbreviated form, natural log to the 4th of x. And remember, x is, for the natural log, x has got to be greater than 0. Okay, the domain of the natural log, if you think of the natural log curve, it's asymptotic to the line y equals 0. I'm sorry, the asymptotic to the line x equals 0. Okay, so, and again, it kind of moves around, moves up like this. So x has always got to be greater than 0, so it's between 0 and infinity. That's the domain. Okay. And the range is all real numbers. Okay, so if that helps.